Welcome guys to today's tutorial. We'll be focusing on inverse variation. Inverse variation. Now, our last lesson we were looking at direct variation. Okay, where it's a bit messy there. Direct variation, hopefully remember, was y equals kx. First of all, I want to look at that word inverse. The inverse of a number. Hopefully you remember, for example, if we had the number 3, the inverse means the opposite of that, or flip it upside down. So for example, if we got 3 over 1, it would be 1 over 3. That's what inverse means. So if we've got y equals kx, okay, we talk about the inverse of that being y equals k over x. Okay, y equals k over x, because it's the inverse of the x that we're looking at. Now, obviously at the moment it's x over 1, so we're flipping that upside down to making it k over x. So again, the formula for inverse variation is y equals k over x. Now, as long as you can remember that, then pretty much everything else is identical to direct variation. We spoke about last lesson the more challenging ones. For example, we said, if y varies inversely with x, then it would be y equals k over x. But we spoke about those more challenging ones, like for example, y varies, this time it will be inversely, the square root of x, okay, which will be exactly the same as last time, but y, in this case it's k over the square root of x. If it's y varies inversely with the square of x, or x squared, then it's simply y equals k over x squared. Okay, so just like the direct variation, you can have those different variations of the formulas. Okay, so we're going to get straight into a question. Okay, so we've got a man's blood alcohol level A after drinking beer varies inversely as his weight W kilograms. So obviously, some people are not sure what difference is between direct variation and inverse variation in terms of how do I know when to use it. And again, you can see very quickly there that it actually says the word inversely. So if it's going to be inverse variation, it'll have inversely in there. Again, we have a keyword there, varies. They'll sometimes put proportional and that type of stuff in there as well. But obviously we can see that. Now, just like last time, even before we start the question, we should be looking for that formula to start off with. Obviously we know that if it's inversely, it's going to be y equals k over x. And we like to put in those letters. Now we know that y varies with x. Okay, in this case a varies with w. So the formula will be a equals k over w. So again, we're putting the letters that they're giving us. So let's look at the question. Write an equation for a. Well, in the actual question, in the blue part, you can see there's no value. So when they ask us to write an equation, it will simply be that a equals k over w. So again, in this case, they've actually asked us to do that. We've already answered the first part of the question. A equals k over w. The second part of the question reads, after drinking, a 72 kilogram man has a blood alcohol level of 0.059. Calculate that constant of variation. There comes that little question up again about the k value, the constant of variation. So they've given us a value there, or two values. So value for A, we know that value of A means the blood alcohol level. Okay, so the blood alcohol level is 0.059. Notice again they've tried to trick us because they've given us the 72 kilograms first. Had we not written that new formula A equals k over w, most people would put the 72 where the y is, okay, or the a is, and that's obviously wrong. So A in this case stands for blood alcohol level, so that's 0.059. We've got our k over, and the weight obviously is 72 kilograms. Okay, so if you've got your graphics calculator, you can tap that in and let it solve. Otherwise, if you want to do it the longer way, opposite divide by 72, simply times by 72. So we're just doing 0.059 times 72. Okay, so if we type that into our calculator, we should get approximately 4.248. Okay, they haven't asked us to write that into the equation, but it just asks us for the constant variation in that particular question. And the last part there says calculate the blood alcohol level to 3 decimal places of a 90 kilogram man who drinks the same as the 72 kilogram man. Okay, drinks the same as the 72 kilogram man. So first of all, let's rewrite that formula that we've got, but with the k value in. So A equals, the k value is now 4.248 over our weight. So we're wanting to calculate the blood alcohol level, which is the A. We've got the 4.248 over the 90 kilogram man. Okay, and again now it's just typing that into our calculator. Either the graphics calculator is fine or a straight calculator because it's a straight division. We should get the answer for A equals 0.047. 0.047. Okay, and that's it. There's nothing different to what we have been doing. Just something I want to point out. Obviously you can see here before it was 0.059 for a 72 kilogram man. Start making sort of use of your numbers. Hopefully you'll notice if you drink the same amount, a heavier person will have a lower blood alcohol level, and you can see that we've got 0.047, which is lower than the 0.059. Okay, so it's pretty straightforward, just like the direct variation. Okay, so what we're going to now do, we're going to do another question. Now, slightly more challenging, but again, it's just exactly the same as what we were doing before with the direct variation stuff. Okay, the weight W of an object is inversely, okay, so keyword there we've come about is that inversely proportional. Look at that. Okay. So the weight of an object is inversely proportional to the square of its distance. That's another important part, because it's the square of the distance, d kilometers from the center of the Earth. Write the variation equation. Well, again, we're going to do that anyway. Okay, so we know it's inverse, so it's y equals k over, but it's not just x, is it? Okay, because it's the square of its distance. So it's y of x squared. Now let's put in the values that they've given us. Y varies with x, so weight varies with distance. So we're going to put in w equals the k over, and it's this distance squared, d squared. We've already answered the first question there. Okay, that's already A. I'm just going to put an A in front of that. Okay, because that's all they've asked us to do that. There's no values in that question, so obviously we can't put the value of k in for that variation equation. Part B, an astronaut weighs 60 kilograms on the surface of the Earth, 64,000 kilometers from the Earth's center. Calculate his weight when he is in space, in a space shuttle, 80 kilometers above the Earth's surface. Well, first of all, we need to put the first two values into the equation to get the value of k, and then we can rewrite that variation equation. So let's rewrite it. We've got the weight of the astronaut, which is a 60 kilogram astronaut, equals k over, and the distance is 64,000 squared. Okay, now again that's going to be a very big number or a very small number, very big number, because we've got divided by 64,000 squared, and we're going to be timesing 60 by that. Or you can put it into your graphics calculator and let it do it itself. Either way, we're going to come up with a k value, and it's going to be a very big k value. I'm going to write this in standard form because it's going to be very big, of 2.4576 times 10 to the power of 9. Or you can write e to the power of 9, which is fine as well. So it's a pretty big number, as you can see. What I'm going to do also, straight under that, I'm going to rewrite the variation equation from part A, but with that value in 2.4576 times 10 to the power of 9, all over the d squared. Okay, so that's our more advanced variation equation, because I've got the k value in there. Now I can answer the question, because it says, this is the question part, which says calculate his weight when he's in space in a special 80 kilometers above. So we're calculating the weight, so we're finding W, so it's simply a matter of putting W equals our 2.4576 times 10 to the power of 9 all over, and our distance we've been told is 80 kilometers. So 80 squared. And again, that's pretty much a straight calculation because it's just divided by, or you can put it into graphics mode if you wish. Either way, to one decimal place, or the 0.1 kilogram, we're going to get 58.5 kilograms. Okay, and again, they might ask you what is the distance of a 40 kilogram man, and so you just put in the 40 where that W is there. Alright, so it's very straightforward. With direct variation and inverse variation, the steps are exactly the same. First of all, remember, get your formula of variation out. So in this case it was W equals K over D squared. If you've given values, you can find K. No matter what's going to happen, you're going to have to find the constant of variation anyway. And then obviously you can answer those questions. All right, go through some questions in your textbook. Any problems at all, make sure you let me know, and I can sort things out for you. Okay, I hope this is useful.